Hey everybody, I wanted to do a quick little video for the first FRQ in Unit 7 on the College Board resources. A couple of you guys asked me about it. So it involves a differential equation, and here we go. You're given a differential equation that's kind of unique in that you can't separate it very easily. And then it gives us a point that at t equals 10, the vat contains 50 pounds, and so I believe it's the independent variable is t, the dependent is the amount. So you have this point 1050. So it says find the line tangent in part A. I underline it because that's the key phrase. Remember, for a tangent line you need a point and a slope, and it kind of follows this form. And so in general we're going to have the dependent variable is a, and it's the amount minus the 50, and then we're going to have t, because that's the independent variable, minus 10. That's the initial condition it gave us. And then we need a slope, and that's where the differential equation comes in. So right in here it says that dA dt is going to be 6 minus 0.02, and we don't plug in 10 for t, we plug in the a that goes along with that t value, and it said that when t is 10, a is 50, so we're actually going to plug in a 50 there. And what we end up getting is the slope, which is going to equal 5 if you simplify that. And so I believe that the equation for the tangent line, and the answer to at least part of this, is a minus 50 equals 5 times t minus 10. And the second part says approximate the amount at t equals 12. So I'm going to rewrite my linear approximation, and then at t equals 12 I'm going to plug in 12 here, and we get 10 plus 50 is equal to a, so a is equal to 60 pounds, and that's the answer to part A. Moving on to part B, it says show that a of t equals this exponential equation satisfies the differential equation dA over dt with initial condition 1050. So I thought this was the trickiest part of all three of them, just because this is not separable. So if you tried to solve this by separating the variables, you had a hard time because of this minus sign in here. But we do know, just with the notation, that dA dt is the derivative of a with respect to t. So I kind of took a little backwards approach on this, and I started with a of t, which is 300 minus 250 e to the 0.2. This was given to us, minus 0.02 t. And I just took the derivative of this, because remember, that's the same as dA dt. And the constant goes away, and this constant's along for the ride, and then the derivative of any exponential is itself, and then times the chain rule, the derivative of the inside of the argument, so you have an extra negative 0.02 in there. And if you combine the coefficients and you multiply that, you end up getting 5 e to the 0.2 minus 0.02 t. And so I interpret the question as we really need to show that this is equivalent to this. And if we can show that, because that's what it tells us to show, then we're done. And so if I rewrite this over here, it's really 6 minus 0.02 times a, but a was given to us as 300 minus 250e to the 0.2 minus 0.02t. And if you distribute this in, you end up getting 6 minus 6, that's the product of 300 and 0.02, and then plus, and then if you do 0.02 times 250, and you do the minus times the minus, you end up getting 5e to the 0.2 minus 0.2t. So you end up showing that they are equivalent. Now that's how I did it first looking at it, so I think I'm done. The only thing I'm not sure about is it says this initial condition, and I'm guessing there's another way to do it that maybe has a shortcut, but it's been a long week and I'm not sure what that shortcut is. So leave a comment in the comment section if you know. It also might just mean that if you did try to work backwards, there's a lot of plus c's that it could be, or maybe it's just using the scenario from part A. So anyway, part C, it asks us to find h of t. That's our goal for this particular differential. So hopefully you remember that the first step is to always separate the variables. So the first step would be to rewrite it like this. Now I actually thought this problem was interesting and different and unique, and maybe that's how they'll mix it up this year, but the thing that makes this kind of unique is there's two conditions or 2 points to consider. And without spoiling too much, what ends up happening is with the 2 points, you're going to use one of the points to find c, and the other point to find k. And because there's 2 constants. And usually speaking, if you have 2 variables, then you're going to need to have 2 points or 2 conditions or two equations or something like that. So anyway, this is going to be h to the negative 1/2 dh. This is just going to hang out for a second. And then hopefully you know after you integrate, after you separate, then you integrate. So I'm going to integrate both sides. And what we end up having is h to the positive 1/2, balance it out. And then we've got on the other side, we're going to have negative kt plus c. And so now I'm going to start using my conditions. So if I take this and plug in 0.16, I'm going to have 2 times the square root of 16 equals what? 0 plus c. So c equals 2 times 4, which is 8. So I'm almost there. So then I got 2 h to the 1/2 equals negative kt plus the 8 that I just found. And now I have to plug in the other value, which was 34. And as you're working on this, it also kind of makes sense when you have this square root in here that they're giving you perfect squares. They're giving you nice numbers. And then over here I have negative k times 30 plus 8. So over here I have 4 equals negative 30k plus 8. Negative 4 equals negative 30k. So k is going to equal 4 over 30, or 2 over 15. So if I want to answer the final question, I've got h of t. Actually, let me rewrite this. I got 2h to the 1/2 equals negative 4 over 30 t plus 8. So I've got h to the 1/2 equals -4 over 60 plus 4. And again, you could rewrite this a few different ways. And then if I square both sides, I've got something like -4 over 60, forgot my t plus 4 squared. Again, I think that looks pretty good. Hopefully it helped out, and thanks for the questions.